Okay. Let's see. Okay, now, first subtopic in chapter 5 is about work done. So, what is the equations for work done? Now, try to recall. The definitions for work done is a W. Is a W. Wait, yeah, it's a bit lagging today. Okay, it's a W. Aha.
Nafas.
Okay. Can see kan?
Dia ke tepi.
Ya lah, memang saya ke tepi sebab saya nak tunjuk nota.
Okey, boleh.
Okay. So, the first things, the definitions for work done is a W equals to F dot S. Okay, that is what we know. And remember, this dot, it doesn't represent multiplication. It represents dot product in physics. So when you have dot product, you're going to change the equations into F as cos theta. Now, in our notes, we just give you F as cos theta, but actually it's the modulus, the magnitude of force, the magnitude of a displacement. Okay, just that because we use a normal character without bow, so that one is already represents the magnitude in our notes. Okay, so when it comes to work done, we use the magnitude of force times the magnitudes of the displacement and then cos theta. The most important thing in this equation is actually the theta. Okay, you need to know how to determine the angles. So this is the angle between force and also displacement. All right. And sometimes you don't even need to look at the calculations. You don't even look at the magnitude of force and displacement. You just look at the angles, then you should know the value. Why? Because some angles, it will give you a result which is equal to 0. All right, which is equal to 0. So now in physics, okay, we often look at these few angles. All right, the first one is a cos 0 degree. Cos 0 degree, it gives us 1. Okay, and then we have cos 90 degree, which then gives us 0. And when it comes to work done, we're going to look at the angles in between 0 until 180 degree. All right, it's from 0 until 180 degrees. So this is the angles that we're going to look at in work done. It's unlike when we do resolving factor, we are looking at the angles in between 0 until 90 only. But when it comes to work done, we have to take into considerations the 180 degree. Why? Because cos function, cos 180 degree, it gives us a negative value, -1. Okay, so it's the difference than sine. So when it comes to the sine functions, sine 0 and sine 180, it gives us the same answer. But when it comes to cos function, you have to be extra careful with the direction. Same directions and opposite direction, it gives a result in the opposite sign. All right. And then another angles that you need to know is a sine 0 degree, which give you 0, and then sine 90 degree, which then give you 1. Okay, so these are the angles that we have to know. Okay, and most of the time, these types of questions, it comes out in objective questions because you don't even need to do the calculation. Straight away, you get the answer. Okay, for example, it asks you, okay, in the following given situation, which force, which situations, which phenomenon give us the maximum works, okay, give us the minimum works done, then they are all based on the angle. Okay, you can determine based on the angle. Okay, now let's look at the work done. Work, okay, we have two types of works. First one is by component. Okay, by component. So by components means that you have to calculate the work done by each force. Okay, by each force. So each force means you are going to look at what? Work done by tension, and then we have a work done by normal force, work done by weight, and then work done by frictional force, and work done by external force. So this is the meanings of work done by each individual force. And then another types of work done that the question will ask us to calculate is the total work done. Okay, total work done. So how to calculate total work done? Once again, it has two methods. Once you calculate the total of work done by each component. Okay, by each component. So meanings that W total, okay, W total is equals to WT plus WN plus WW plus WF plus W external force. And then the second part, the second method that can be used is straight away by using total work done, okay, by using the net force. Total force, your resultant force, F net, okay, times S, and then cos theta. So this is the second method. So both methods you need to know, okay, because sometimes the questions will ask you to use a specific method to solve it, or it can only be solved by one of this method. Okay, so you must know both of them, right? Both this method, the W total, okay, the one that you use net force, and another one's where you add up all the work done by each individual force. Okay, so this is the summaries of the work done. Right, we have the definitions, and then we look at how to calculate the work done, and then we need to know what is the importance of angles in our calculations. Okay, and then now we are going to try to solve this question. Some questions can be solved by using two different methods, and in these first sections I will show you both methods. Okay, because of what? Because now you got plenty of online reference. You got on a lot of YouTube video from lecturer A, from lecturer B, from lecturer C, and then you have all the software notes. Okay, the notes from website A, the notes from website B, all of them they uses different method. Okay, and it doesn't mean that they are wrong. That's why I want to show you both so that you don't get confused. All right. So first one is very simple. First one you have only one method. Okay, so first one, now you have a force going to the right-hand side, and then displacement also going to the right-hand side. When two of them, they are pointing towards the same direction, then we say the angle is equal to 0 degree. Okay, so by applying W equals to Fs cos theta, then we have 5 times 10 cos 0 degree. Cos 0, it gives us 1. Okay, therefore straight away is equals to 50. The unit for work done is joule. So 50 joule. All right, 50 joule. So this is the first questions. Now let's look at second questions. Second questions, we are going to apply. Okay, well, wait, yeah. Okay, now the second method that we are going to use is okay, we try the first, the one in the red color first, which is a W equals to Fs cos theta. Okay, we use the method that is same as the above one first. Okay, that is the first method. Okay, now straight away, you just substitute F equals to 5, and then S equals to 10, and cos. Okay, cos angle is the angle between them, which is a 60 degree here. Okay, so cos 60 degree, which then will give you 25 joule, because cos 60 is 1 over 2. Okay, cos 60 is 1 over 2. So now you have 25 joule. Now let's try second method. Some books, they don't do like this. Okay, what they did, they resolve force first. Okay, so they resolve the force. So what does it mean by resolve the force? Now you look at the diagram. If you resolve the force, you will get an Fx that is pointing towards the same directions as your S. Okay, so they use this Fx in their calculations. So W equals to Fx as cos theta. Now you still keep this cos theta, okay? Just that when you expand this equation, it will now becomes, okay, now your Fx, okay, Fx component is a F, which is 5 cos 60 degree. Okay, and then times with the S, which is the displacement, 10, and then you need to keep the cos again, because this cos is part of the equations. You cannot just remove it from an equation. But then what should you put in the second cos theta? Second cos theta, now you look at fx and s. Fx is going to the right hand side, s is also going to the right hand side. So now both of them, they are pointing towards the same direction. So cos 0 degree, okay? Which means now the second cos, the functions of this second cos theta, it gives you the sign conventions only, either positive or negative. If same direction, then it ends up as 1, which is a positive value. If opposite direction, it ends up as a -1, then it is a negative value. Okay, so we calculate it, eventually you're going to get 25 joule as well. So the method in a green color, now you have two cos, just because they resolve force first. They want to make sure the force is lying on the same axis as your displacement. Okay, it's lying on the same axis. So there are two methods. Okay, so first method is the one in the red color. The second method is the one in the green color. Okay, now let's look at question C. Question C, very simple. You don't even have to calculate it. Okay, but of course now in exercise, I'm going to show you the calculation as well. So W equals to Fs cos theta. Okay, so you have an F, which is 5, and then S, which is 10. Now, cos, you look at the diagram. Now, F and S, they form a 90 degree. They are perpendicular to each other. So, cos 90 degree. That is why I told you, I say just now, you don't even have to calculate it. Because cos 90 give you 0. Straight away, the final answer is 0 joule. Okay, so if the directions of force is perpendicular to the directions of motion, then that force basically it did nothing. Okay, it doesn't do any works. Okay, so that is the second, that is the third questions. Now let's look at the fourth questions. The fourth questions, now if you look at the questions, the angle is now 120 degree. Okay, how do I know it's 120 degree? Because now my S is going to the right hand side, and my force is going to the left hand side. So the angle need to, okay, you need to rotate the angle from the positive axis. Okay, you need to rotate the angle from the directions of the S. So S is on the right hand side of the force, so you rotate it, therefore it gives you 120 degree. Okay, it forms a 120 degree in the XY plane. So now what am I going to do? W equals to Fs cos theta. So which is then equals to 5, and then the S is the 10. So cos, now remember, you need to use 120 degree, right? Which is then equals to, okay, equals to a -25. -25 joule. So that is the answer for questions D. Now, what if I want to use a green color method to solve it? So you resolve this force. But when you resolve this force, okay, now, okay, what is going to happen here is that you will have the Fx that is going to the left-hand side. Okay, so this is your Fx. So you resolve it first. Okay, so W equals to Fx as cos theta. So my Fx is now 5 cos, okay, how many degree? Again, it's a 60 degree. Okay, cos 60 degree times with S, which is 10 meter. But now, what should you write in the second cos? Okay, you look at the diagram. My Fx is going to the left-hand side. S is going to the right-hand side. So it forms a 180 degree between them. That's why I told you, in the second method, this second cos, actually, it just gives you the sign convention, right? So now you know that cos 180 degree, it gives you -1, and then 5 cos 60 times 10 gives you 25. So the end product is -25 joule. Okay, -25 joule. So in the previous questions, where we have cos 0 degree, we end up say +25 joule. Now we have 180 degree, it ends up -25 joule. So the method in a green color, actually, it just gives you the directions, okay, the sign conventions in your final answer. So what does it mean by negative? Negative means energy loss. okay, the work done to overcome the frictional force, for example. Okay, so that one is considered as energy loss. So the last question is just a W equals to Fs cos theta. Okay, so F is 5, S is 10. Now you have cos again 180 degree. So it gives you a negative 1. So negative 1 times 5 times 10, it ends up negative 50 joule. Okay, negative 50 joule. So that is the answer, the complete answer for exercise 1. So now I give you, I give you 2 minutes to tidy up your answer. Okay. Okay, so can see everything, should be. So now you just tidy up, okay, write down the things that you want to write, the notes, the summary, and then the answer for 5 examples. Okay, so I give you until 2:20, okay, 20 past 2 to complete this section.
Madam,
Yes.
boleh ke kalau macam work tu,
Mm-hmm.
kita macam work tu jatuh? Maksudnya dia guna sing. Boleh ke?
Hah? Dia apa?
Dia macam WFS sin theta. Tak ada kan?
Itu kalau kamu guna angles, macam mana nak kata? Dia boleh, cuma dia kurang sesuai.
Dia guna
Sebab kamu kena main dengan X and Y axis juga yang itu. Okay, so macam kamu punya cos 60, kalau kamu guna sin 60, sama aja dia punya jawapan actually. Tetapi kamu kena tahu macam mana nak tukar.
Okay.
Okay, cuma yang lebih tepat anda kena guna cos theta because that is part of the definition. So itu yang lebih proper kita kata. Alright. So, yeah. Okay, you guys do first. My mouse is out of battery. I got to get a battery first. Okay, now let's see how to solve this as second questions. Okay, how to solve this as second questions. So second questions basically is quite similar to the first one. Okay, what are we going to do now? We are just going to draw a free body diagram first. So it is always a good idea to draw a free body diagram, like what we have been doing in a previous chapter. Okay, because you need to identify how many forces do we have acting on the object. Okay, and then in order to determine the work done by each component. Okay, each components of the force, each forces. Or you can use your free body diagrams to calculate resultant force first before you calculate the total work done. Therefore, free body diagram also plays a very important role in this chapter. So now you push your physics reference books, which is 1.5 meter along a horizontal table with a horizontal force. The frictional force is 1.6 Newton. Calculate the work done by 5 Newton force, by the frictional force, by the weight, and by the normal force. So that is what I told you just now. Okay, this is the work done by each component of force. Okay, by each force. So let us draw a free body diagram first. So now you have a books. Okay, you have a books. This is the object. Every object, it comes with a weight. So you have a W that is going down, and then you put it on the table. You put it on the table means that there would be a normal force going up. Okay, normal force that is going up. And now you push it with a horizontal force. So you push it, now you have an external force. Okay, external force. And then it experiences a frictional force in the opposite direction. All right, so this is a free body diagram. So since you push the object, let's say now according to my diagram, I push the object to the right. Therefore the displacement is to the right. So this is my S, okay, which is equals to 1.5 meter. So this is a free body diagram based on questions, okay, that I obtained based on the explanations given in the questions. So now I'm going to solve them one by one. So W, okay, I'm going to follow the sequence in the questions. So work done by 5 newtons of force by external force is equals to Fs cos theta. All right. So my force is a 5 Newton, and then object moved by 1.5 meter. So cos, okay, now my F and my S, they are both pointing towards same direction. So 0 degree. So it is equals to 7.5 joule. All right. And then the second force that I'm going to calculate is the frictional force. So W, friction, work done by frictional force. So now when it comes to calculations, make sure you use the right symbol. Okay, now you're looking at the frictional force. So small letter F. Okay, frictional force S cos theta. So which is then equals to, okay, given frictional force is 1.6 and then S is 1.5. Now cos 180 degree. Okay, which is then negative 2.4 joule. So it means that you have a energy loss that is equivalent to 2.4 joule if you want to move this object by 1.5 meter. Okay, so this 2.4 joule is being used to overcome friction on the table. All right, and then the next one, I'm going to calculate work done by weight. So you don't get confused. In this chapter, you have two W. Okay, the first W that I put on the left hand side is the work done. The second W that I put in the equation is the weight, is the force. Okay, so Ws cos theta, which is then, okay, equals to W. Now I don't have W, but does it matter? It doesn't matter. So I can even keep S in my equations. Why? Because now I know the angle is equals to 90 degree. So when you have angles, okay, cos 90 degree, straight away your answer should be equals to 0 joule. All right, because there's no work done along Y component since your object is moving along X component. So what is the work done by vertical force? Nothing. Okay, because it doesn't move your objects along the Y component. So no work is being done on the Y component. And therefore, your summations F is always equal to 0, right? When it comes to this type of questions. So W, the last one is normal force. Wn equals to Ns cos theta. Okay, which is then equals to, now normal force again, I don't have it. But then what I do have, again, is 90 degree. Therefore, it is equals to 0 joule. Okay, it is equals to 0 joule. So in exam, you just have to show cos 90, then straight away equals to 0. Then that is enough. Okay, you need to show cos 90. You cannot straight away give 0 joule because cos 90, actually, I think it's worth 1 mark if I'm not mistaken in your exam. Okay, now questions B. Questions B, it asks you to calculate total work done on the book. Okay, so how to calculate total work done on the book? Simple. So W total, okay, straight away equals to WF plus WF plus WW plus WN. Okay, which then give you 5.1 joule. All right, which then give you 5.1 joule. Now, the second method that you can use, okay, like I told you just now, every total work done, okay, every total work done, it can be solved by using two different methods. So now you look at the diagram. Diagram shows you S is moving along the horizontal component. Therefore, what we can do, we can calculate W total by using Fx. Okay, this one we can use Fx because now our displacement is along the x component. All right. If it is not, then maybe you need to calculate resultants of all four forces. So Fx as cos theta. Fx, how am I going to calculate Fx? Now I have one force going to the right, another force going to the left. So my S is going to the right. So I'm going to take right hand side as positive, left hand side as negative. So F minus friction, and then S cos theta. So F minus friction is F is a 5. Okay, so 5 minus 1.5. So 5 minus 1.6, sorry, 1.6. 5 minus 1.6, which then give you Fx going to the right hand side. Okay, because it is a positive value. If you get a negative value, then you need to use cos 180 degree, right? So and then S is a 1.5. Now, because your Fx and your S, they are going to work same direction. So cos 0 degree. Okay, cos 0 degree. Let me rewrite it. Okay, now it's correct, yeah? Just that it's not tidy, so I rewrite it. So 5 minus 1.6 times 1.5 and then cos 0 degree. Okay, therefore, you're still going to get 5.1 joule. Okay, 5.1 joule. If you get Fx in the opposite direction, then you need to use cos 180 degree. So this is a second method. Okay, this is just a second method. So you have two methods that can be used to solve questions B. Again, the one in the blue color and the one in the green color. So now I give you 2 minutes to write it down. Okay, bagi Anda 2 minutes untuk kemas kini. So you can write down both methods so that you know what is the difference between these two methods. Okay, what is the difference between these two methods? All right. Now let's look at the next question. Next question basically is very similar to this question. Okay, just that now they changed the plane a little bit. Okay, so now you have an inclined surface. Okay, now let's see. An object of mass 1.5 kg is slide downwards on a smooth inclined plane. And the length, okay, the length, which is here, the S, is equal to 25 meter. Okay, so the length of this inclined surface is 25 meter. But if you look at the questions, it asks you to determine what? Determines the work done by gravitational force only in order to displace the object from A to C. So you just need the work done by gravitational force. You are not looking at the resultant force. You are not looking at every single component. What you are looking at, you are just looking at the gravitational force, okay, which is the weight of the object. So if you look at the diagram, okay, weight is always pointing downwards. So this is the directions of weight. Okay, so directions of weight is here. Then what is the angles between your S and your W? So if you recall, this 20 degree given is the 20 degree for Y component, okay, beside Y component, in which it means the angle between S and W is actually 70 degree. Okay, it's actually 70 degree. So now I can determine the work done by gravitational force. So WW equals to W S cos theta. Okay, but then I don't have the weight. Okay, I need to calculate it by using mg. So mgs now cos 70 degree, which is then equals to 1.5 times 9.81 times with an S, which is 25 meter, and then cos 70 degree. All right, eventually you're going to get 125.8 joule. So that is how you solve this question. All right, it is very simple as long as you understand the question. So this question is asking for work done, yes, but it is not total work done. It just wants the work done by gravitational force. Okay, work done by gravitational force. Okay, now, after you determine the work done by gravitational force, what if you want to use a second method to solve it? Can or cannot? Of course you can. Okay, of course you can. Because now your W is lying in between X and Y component, you can resolve it into W, X, and then WY. But in these questions, what we want is just a WX, because WX is lying on the same axis as our displacement, as our S. Therefore, okay, the second method, WW is equals to WX. S and then cos, now you look at the diagram, okay, the diagrams that I sketched, WX and S, now they are pointing towards same direction. Change the color. Okay, so they are pointing towards same direction. So in that case, I'm going to use cos 0 degree. Okay, cos 0 degree, which is then equals to, now, WX mg cos 70 degree. Now, of course, you can use mg sine 20 degree. Okay, that is fine. And then your S, which is 25, and again cos 0 degree. Okay, cos 0 degree, because after you resolve it, WX and S, they are pointing towards same direction. So eventually you will get 125.8 joule as well. Okay, so you have two methods. Method 1 and then method 2. Okay, both of them, they are correct. Okay, both of them, they are correct. So again, I give you 1 minute to tidy it up, okay, to write out the answer. This is a very simple question. And once you are done, okay, once you are done, I want you to spend 5 minutes on trying questions 3. Okay, I give you 5 minutes to try questions 3. So I will continue after this. Okay, I'll continue after 5 minutes. I want you to try questions 3 by yourself. So questions 3 basically is the combinations of questions 1 and 2. Okay, it combine 1 and 2. Okay, you learn how to calculate force, work done by component, by each force, and then how to calculate the total work done. Okay, so you're given the free body, the diagram already. Okay, so you can have a free body diagram, or you can use the original diagrams here. It's fine. So from here, you try to think, how are you going to solve it? So 5 minutes from now, I want you to try it. See whether you can get the correct answer or not. All right, so now let's go through the answer. Okay, I hope you can get the right answer, of course. No, if you stuck, then we are going to check it, go through it together. Don't worry. All right. So how to solve this question is very simple. Now let's go through the question first. A box of mass 20 kg now move up on a rough plane. Okay, so the important information in this sentence is that now you have a rough plane and then it's moved up. Okay, now the object slides up, not sliding down. Okay, it slides up. And then the inclined surface is 25 degree above horizontal. So it is pulled by a horizontal force. Now, in these questions, the tricky part is one. When it comes to horizontal force, okay, students always got a misconception. Sometimes questions, they won't give you a free body diagram. And then they tells you object is being pushed by a horizontal force. What does it mean by horizontal force? Horizontal force is as shown in this diagram. It is truly horizontal. Okay, it doesn't mean it is parallel to the surface. That is a misconception that students always have. Okay, whenever questions mentions horizontal force, it truly means horizontal. It doesn't represent parallel to the inclined surface. Even though now we assume inclined surface is our x component, and then the surface that is perpendicular to it is a y component. But when it comes to the questions, when it comes to a statement, it tells you horizontal force means it is really truly horizontal. Either it's going to the right or going to the left. Okay, it doesn't mean parallel to the surface. So one puzzle questions, I think you need to sketch this free body diagram by yourself. Okay, and it mentions the terms horizontal force. So you need to know horizontal force is like what you have in the diagram. Okay, the red color arrow here. Okay, it is not parallel to the surface area, not parallel to the inclined surface. So it's being pulled by a horizontal force. The coefficients of kinetic frictions given is 0.3, and then the S given is 3.8. Okay, so you have S equals to 3.8 meter. So the work done on the box by force, by gravitational force, by reaction force, and by the frictional force. So questions, now it asks you to determine the work done by each individual force. Okay, so how are we going to calculate it? Let's begin with a force. Okay. Okay, now I think it would be easier if I resketch the diagram. So now I have a force going to the right hand side, and then I have a weight that is going down, right? And then, okay, this is my x-axis, my x component, and then this is my y component. So I have a normal force going toward this direction, and then I have a friction going backwards. Okay, so this is friction, and then this is normal. And then my S is going to the positive X component, okay, positive X component. So before we start, it would be easier if we determine the angle first. Okay, the angles. Which angle is the most important angles? The angles between S and also the horizontal force, the displacement and also the horizontal force. Okay, why? Because N and S is just 90 degree, frictional force and S is just 180 degree. In order to determine the angle between work done and the displacement, you need this angle. Okay, so this angle is the most important angles in the whole questions. So how to determine the angle? So given inclined plane is 25 degree above horizontal, so which means 25 degree is beside, okay, is between y components and weight. Okay, this is 25 degree. So this is 25 degree. It means the neighboring angle is 65 degree, which then give you this one is also equals to 25 degree. So angles between displacement and the horizontal force is also equals to 25 degree. Okay, it is also equals to 25 degree. So that is what we have right now. Okay, so now we can calculate the work done. So A, okay, I'm going to follow the sequence again. So WF is equals to Fs cos theta. Okay, which is then equals to, so given the horizontal force is 250 Newton, and then times with the displacement, which is 3.8, and cos, okay, cos 25 degree. which give me 861 joule. Okay, 861 joule. The second one is a gravitational force. So W equals to, okay, so work done, and work done equals to weight S cos theta. Now W, you don't have it. What you do have is the weight, 20 kg. Okay, so 20 kg is mg, so mg times with S, which is 3.8, and then cos. Okay, now what is the angle between W and S? So you look at the diagram, my W is going down. Okay, my W is going down, my S is going up. Okay, it's going to work this direction. So that is the angles that we want. Okay, that is the angles that we want. So angles between S and W, according to the diagram, is 90 degree plus 25 degree. So 115 degree. Okay, which then give you a negative, okay, negative 315.1 joule. Okay, 315.1 joule. Okay, and then the next one, I'm going to calculate is the reaction force, which is a normal force. Okay, so W normal is equals to NS cos theta, which is then equals to the normal force. Do I have the normal force? Well, apparently I don't have the normal force. But what I can do, I can calculate it. I can calculate normal force by using Newton's law. Okay, so my object is moving along the horizontal component. So what do I have along x component? It's just a normal force with what? With Wx, not Wx, sorry, Wy. Okay, Wy and also Fy. Okay, so you need to resolve W and F because they are not lying along the x component. Okay, this is our x component and this is our y component. They are not lying on the x or on the y component. They are lying in between them. So what we can do, we can actually calculate normal force by using Newton's first law. Okay, because my object is moving along x component, so there's no motions along y component. So summations Fy equals to 0, n minus Wy minus Fy equals to 0. Therefore, n is equals to mg cos 25 degree plus F cos 65 degree, which then give you the normal force is 283.5 Newton. Okay, you yourself try to calculate it, see whether you can get the right answer or not. Right? So now, okay, now that you change it, okay, now you calculate it, you can then substitute into the equations. So 283.5 times with S, 3.8, and cos, okay, now what is the angles between them? Okay, cos, well, basically just a 90 degree, all right? So which is equals to 0 joule. So basically you don't even have to calculate it. But in case you need to calculate it, that is how you do it. Okay, but I think you still need it. Why? Because we don't have frictional force. So now let's see how to calculate the work done by frictional force. WF equals to Fs cos theta. We don't have frictional force, but what we know is F is equals to mu n. Aha, so we can still use the n in our calculations. So mu given is just now mu given is 0.3. 0.3 times with the n, which is a 283.5. Okay, and then the S is a 3.8 cos 180 degree. Okay, because my frictional force and the displacement, they are pointing in the opposite direction. Therefore, it gives you negative 323.2 joule. So this is the answer for work done by frictional force. Okay, work done by frictional force. So now I give you some times to write it down. Where is my cursor?
Madam,
Yep.
boleh ke kalau macam frictional force tu dia punya angle dia tak 150?
Apa?
Kalau frictional force
Aha.
dia punya angle tak 180? Kalau lebih pun ada juga kan?
Rasanya tak mungkin sebab kita punya displacement, arah pergerakan sentiasa bertentangan arah dengan kita punya friction. So dia sepatutnya sentiasa 180 degree.
Okay.
Yeah. All right. Okay, so work done by 4 forces, you can write it down first. Okay, you can write it down first. So far empat work done ini boleh faham kan? Okay, so Anda kena pastikan bagus. Anda kena pastikan Anda faham 4 jenis work done ini. All right, so next, questions B. Okay, questions B, total work done, just very simple. So W total straight away equals to your WF plus WW plus WN plus WF. Straight away equals to 222.7 joule. Okay, so now if you want to use a second method to calculate it, can or cannot? Yes, you can. Okay, so you look at the diagram. My S is lying along the X component. Therefore, again, I want to calculate the total force along the X component. So how to calculate total force along the X component? Summations Fx equals to, okay, I will resolve my Fx. So Fx will be in the same directions as S. And then W is in the opposite directions, Wx. So it is equals to capital letter F, the external force along the X component, minus Wx minus friction. Okay, so I will obtain 250 and then cos 25 degree minus, okay, my W is a mg, so 20 times 9.81 cos 65 degree, and then minus my frictional force. So frictional force, now I have a 0.3 times 283.5. Okay, so ends up you obtain the value and then you just calculate it by using W total equals to total Fx S and then cos theta. So if it is a positive value, and I think it should be, then it will be, okay, summations Fx as cos 0 degree, which will also give you 222.7 joule. Okay, 222.7 joule. So that is the second method. All right, the second method. So sometimes you have no choice but to use the second method to calculate it. Okay, kadang-kadang memang dia tak bagi Anda pilihan. Anda cuma boleh guna kaedah kedua. That's why I always shows you both method. Okay, because I want you to understand. Okay, you have more than one method to calculate work done. And in fact, second method is the common sense method. Okay, quite often we will see this method in our examples, in our questions. All right. So again, so I give you a few minutes to write it down. I think we will continue again at 3 p.m. So 3 minutes for you to write it down and then take a short break. Okay, take a short break.
Madam.
Oh, I tak buka mic. Okay, now, okay, I'm going to repeat it again then. Okay, now, if you look at these questions, okay, now these questions, It tells you the components Fx of a variable force, which is parallel to the x-axis. It gives you force along the x component. Why? Because your object is moving along the x component, which is displacement x, in a way as shown in figure. So determines the work done on an object by the force component if the object is displaced from 0 to 20 meter. So from 0 to 20 meter, basically it covers the whole graph. Okay, it covers the whole graph. And how to calculate this work done based on the graph given? So always write down the first statement. Okay, work done is equals to area under Fs graph. This statement is very important. It gives you 1 marks. Why? Because it represents you understand the concept of a Fs graph. Okay, it means you understand how to calculate the work done based on the graph given. And I always encourage my students to write down this statement. Why? Because sometimes you forgot to check the unit. Okay, and in calculations you use wrong unit. Therefore, your final answer is wrong. In that case, you won't even get this 1 mark. Okay, because your final answer is wrong. If your final answer is correct, sometimes we will give you this concept marks. But if you get a wrong unit or you make any careless mistake in your calculation, straight away you're going to get 0 mark without this statement. So it is always a good idea to write this statement to show the examiners that you understand where is work done, where to find the work done, how to determine the work done from the graph given. All right, to prevent any careless mistake that you make in your calculation. Okay, now work done equals to area under Fs graph, which is then equals to, now you look at the graph, it is a triangle. So 1 over 2 times the base, which is 20, and then times the height, which is 10. Okay, 1 over 2 times 20 times 10. So eventually you're going to get 100 joule. So that is questions 4. A very simple questions, and these questions usually it worth 3 marks. 1 marks for the concept, 1 marks for the substitution, and 1 marks for the answer. All right. But if you didn't write the concept and you make any careless mistake in your substitutions or in your final answer, or maybe you got the wrong unit, okay, then straight away you obtain 0 mark. You get 0 mark. So always a good idea to write the first sentence. Okay, it won't take up a lot of time. Just maybe 2-3 seconds to write this phrase. Okay. So questions number 5. Questions number 5, the force on the body varies with displacement from point O as shown in the graph. Calculate the work done when the body displaces from 0 to 4 meter, 0 to 0.4 meter, which is the first part of the graph, and then from 0 to 0.8 meter, which include this negative part. Okay, now let us do first part first. Okay, so from S0 to S0.4, how are we going to calculate it? We want the area. Okay, we want the area. So W, okay, it's W, I'm going to call it WA, okay, because I'm looking at questions A. So WA equals to area under Fs graph. Okay, this is what I told you. Every time we start from this statement, this sentence. Okay, we start from this sentence. And then, okay, what are we going to do next? Okay, we then calculate the area. So area for the first section from 0 until 0.4. Now this is again a triangle. So 1 over 2 times the base, which is 0.4, times the height, which is 4. So it is equal to 0.8 joule. Okay, it is equal to 0.8 joules. So for questions B, now you want to calculate the S from 0 until 0.8. What can you do in this case? So now you have W, the work done for the first part already. So we want to focus on the second part. Okay, and I'm going to call it B. Okay, this is my WB, this is my WA. So WB, okay, now I don't need to write this statement anymore because I already showed it in the first calculation, questions A. All right, so usually if you use it in the same questions already, then the marks won't be given for the second times. So even though it is still using the same concept, area under Fs graph, but now you don't have to write it because the marks is given in questions A already. So WB is now equals to 1 over 2 times the base. Now how to calculate the base? 0.8 minus 0.4. And then the height. Now you need to include the negative sign. Okay, because now you have a negative force. So negative force, you will have a negative work done, which is the energy loss, okay, which represent energy loss. So negative 2. So it will give you negative 0.4 joule. Okay, after you obtain negative 0.4 joule, we then calculate total work done from 0 until 0.8. So W total is then equals to WA plus WB, which is equals to 0.8 plus negative 0.4, which then give you 0.4 joule. So this is questions number 5, right? This is questions number 5. Okay, so if you are done, okay, I give you 1 minute to write it down. If you are done, you can try the following questions. Question 6 is exactly same as this question, just that now the shape, they change it from triangles to trapezium. Okay, so 1 minute for you to write it down. Make sure you know how to do it, and remember to include the negative sign. Okay, negative sign is very important.
Madam,
Yes,
can you go to the question 6?
of course I can. I'm just waiting for you guys to finish writing it down.
Oh, please. Okay, sorry. Done.
Okay, so question 6. So question 6, they just change the shape from triangles to trapezium. Okay, from triangles to trapezium. So now I give you 2 minutes, you try to do it. Okay, this is a very, very, very simple questions. You should be able to solve it within 2 to 3 minutes. Okay, so horizontal force F is applied to a 2 kg radio control car as they move along a straight track. The force varies with the displacements of the car as shown in figure. Calculate the work done by the force, okay, when the car moved from 0 until 7 meter. So basically it's asking for the whole graph, okay, the area of the whole graph. So total work done, okay, W total equals to area under Fs graph. Always begins with this statement. So it is equals to, now the first part of the area, okay, is a trapezium. So 1 over 2, the base is 6. Okay, 6 plus the upper part is 5 minus 3, which is 2, times the height 5. And then plus the triangles, 1 over 2 times 1 times negative 4. Okay, so even though you know that you should use the positive area to subtract the negative area, but in our calculations, we are still going to use the positive sign, okay, because we calculate total area, just that we put a negative in our substitutions of area in the force. Okay, so it is equals to 18 joule. All right, it is equals to 18 joule. So done, very simple. Okay, very simple. As long as you know work done is equals to area under the graph. All right. So now we take a short break, which is a 3 minutes break before I proceed to the next subtopic. Okay, so that marks the end of subtopic 5.1, work done. So next part, we are going to proceed to conservations of energy. Okay, so before that, we take a quick break. 3 minutes. Okay, so kita sambung lagi pada 3.15. Okay, so let us continue. Okay, continue 5.2. So 5.2 is a new subtopic. Okay, we're involved energy now. Okay, so before we do exercises, let us do a quick recap once again. So energy in this chapter, we have 3 types of energy. Okay, now we're going to focus more on what we call mechanical energy. Okay, mechanical energy. So mechanical energy, there are 3 types. The first one is a kinetic energy, and then we have gravitational potentials energy, and at last we have what we call elastic potential energy. And every single one, they have their own equations. So kinetic energy, K is equals to 1 over 2 mv squared. Potential energy, okay, UG is equals to mgh. And then elastic potential energy, US is equals to 1 over 2 kx squared. Right? So kinetic energy, if you recall, it depends on what? It depends on motion. Okay, if your object is moving, then it comes with kinetic energy. Okay, and then the second one, it comes from positions. Okay, positions of the object. If there is a change in the height, it means there is a change in gravitational potential energy. Any object that you place above certain height, it comes with potential energy, gravitational potential energy. All right, and then the last one is depends on the state. Okay, what does it mean by state? The state of compressions, okay, compress or stretch. Okay, it depends on whether you stretch the object or you compress the object. All right, so now you have 3 different energy. All right, now when it comes to mechanical energy, okay, mechanical energy in a closed system. Now, what does it mean by closed system again? Closed system means it's not being affected by any other factor. There's no energy loss, nothing. It's in an ideal situation. Then we say summations E initial, which is the total initial mechanical energy in the system, equals to total mechanical energy, final mechanical energy in the system. Before and after is the same. Okay, or throughout the system. Okay, it doesn't matter which positions, which locations that you are looking at. So in which we can then say K initial plus UG initial plus US initial of the system is equals to K final plus UG final plus US final of the system. Now, if you notice, I keep stressing on the on the terms system. Why is it important to look at the energy in the system rather than object? Okay, energy in the system, it can have more than one object. If you have two objects moving in the same system, in the same situations, then you need to calculate the energy from both of them. All right, that's why if you notice, I don't use the term total energy of the object. I use the total energies in the system. Okay, in the system, because sometimes you can have more than one object in the system, right? And then what else do we have? Now, if your object experience energy loss, okay, sometimes, okay, you have a frictional force, you have an external factor, it is being affected by external factor, then it comes with energy loss. So if it comes with energy loss, then you need to modify the equations a little bit by using summations E initial plus energy loss equals to summations E final. Okay, summations E final. So when it comes to these equations, what does it mean by energy loss? Okay, energy loss is then, okay, this energy loss, yeah, now we're going to focus more on energy loss. Energy loss in our syllabus, it often refers to work done by frictional force. Okay, work done by frictional force. And what we know, work done by frictional force is always Fs cos. Now, just now you asked me, the angle is always 180 degree, ka? Yes. Okay, cos 180 degree. Because you will get a negative value. You need a negative value to represent the energy loss. And why 180 degree? Because S is the directions of motion. And if you recall the definitions of friction, okay, it means the directions of frictional force. We always use the direction that is opposite to the directions of motion. Okay, so S is the directions of motion. And then the way we use to determine the directions of friction is always opposite to the directions of motion. Therefore, F and S, they are always 180 degree. Okay, they are always 180 degree. So now let us go back to the first questions. Very simple questions. An object which is 5 meters above the ground is released from rest. Okay, from rest, the term itself is very important. And then determines the speed of the object when it is 3 meters above the ground. So this question is a bit tricky. Why? Because usually we have an object, we calculate the object before you drop it and the object when it reaches the ground. But for this question, what it wants, okay, now this is the initial position, which is 5 meters. It wants you to calculate the speed at 3 meters from the ground. Means that it hasn't reached the ground yet. Now, when it comes to energy questions, okay, the conservations of energy questions, you are the ones that determines where is our zero mark. Okay, where is our h equals to 0? For these questions, I'm going to use this part as h equals to 0. Okay, of course, you can use the final positions of the ball as h equals to 0. Then your initial height will be 2 meters. All right, it's up to you. Okay, you can also use here as h equals to 0. But then I don't like to change my h equals to 0 from ground. Okay, I like to use the ground as h equals to 0. So h equals to 0, I take ground as h equals to 0. So now what do I have? Okay, first, initial state. Okay, at initial position, the information that I have is v is equals to, initial speed. U is equals to 0. U is equals to 0, it gives me a very important information, which is my kinetic energy is equals to 0. Right? Means that at its initial state, there's no kinetic energy. And then my h is a non-zero value. Therefore, I can conclude that my UG is a non-zero value. There's no spring, therefore no US. And then let's look at what happens at the final state. Final state, V is a non-zero value. Therefore, it tells us our K is also a non-zero value. Now, our H is 3. It is also a non-zero value. Therefore, our UG is also a non-zero value. Okay, so now we can form equations. We can form equations by using conservations of mechanical energy. So summations E initial equals to summations E final. Now, even though we know K initial is always equals to 0 in this situation, I'm still going to write it down, okay, to make it look complete. So K initial plus U initial equals to K final plus UG final. According to my analysis in a diagram, okay, I have K initial equals to 0. So I'm just going to cancel it. Okay, I write it down first, then I cancel it. So I cancel it. So the remaining part will just be U initial equals to K final plus U final. So MG H initial equals to K final plus MGH final. So my M, okay, now I don't have M. I don't have M. Well, it doesn't matter. Why? Because I can cancel it out from the equations. Okay, I forgot to expand the equation for K just now. So let me rewrite it. Okay, let me rewrite it. So K is 1 over 2 mv squared. Okay, so plus mgh final. So I don't have the information about the mass of the object, but it doesn't matter. Why? Because if you look at the equation, all three terms, they come with m. I have m here, I have m here, I have m here. And they all coming from the same object, which is the this ball. All right, so which means I can straight away cancel it. Okay, I can cancel it from my equation, provided all terms, all u, k, and u, they have the same m. They have the same mass. So what am I going to do next? I'm going to substitute. Okay, u equals to 9, h equals h plus g equals to 9.81. Initial h is 5 meter plus equals to 1 over 2 v squared plus 9.81 h final, which is 3. Rearrange the equations, you will obtain v equals to 6.26 meter per second. Okay, so this is our final answer. The answer for questions 1. All right, so now what am I going to do? I'm going to give you some times as usual, okay, to write down the things, okay, all these informations. Okay. Yeah, I think that's it. So including the summary, if you want to write it down, you can write it down. Okay, it can help you in your calculations. And then the answer. So I give you 5 minutes to write down the summary and also the answer before I proceed to next questions. So if there's anything that you don't understand, make sure to ask. Okay, make sure to ask.
Madam,
Yes?
if lah kan,
Mm-hmm.
saya tak ingat yang second formula, yang second, but I remember yang third punya tak apa tu.
Apa maksud yang kamu tak remember second punya formula dengan
second row, sorry.
Oh, kamu tak tulis K initial plus UG initial.
Tapi ingat yang MG tu.
And then kamu ingat yang MG tu.
Ah.
Dia actually boleh, tak ada masalah. Cuma yang K initial plus U initial equals to K final plus U final itu, dia dianggap sebagai konsep. Tapi most of the time apa yang terjadi dalam exam, dia tengok dua ini. Okay, dia bagi markah konsep kepada salah satu. So kalau kamu ada yang first punya, okay, the second row ini, kalau tak tulis, actually dia tak ada masalah juga. Okay, either one, biasanya dia dapat satu markah.
Okay, faham.
Okay, so let us move on to the next question. Next question is also a very simple questions. Right, let's see. Mhm. Okay. So next question, this question, you want to test your concept actually, all right? You want to see whether you understand the meanings of conservations of energy. So if you look at the diagram, now your object, okay, the object is start from maximum height. Okay, it start from maximum height, and then what happened? So determines the speed of the object when it reaches point B and also point A. So you have object, this is the initial state, okay, initial, I'm going to call it initial. And then you have point A and point B. Now, if you truly understand the meanings of principle of conservations of energy, then you should know that summations E at initial state is equal to summations E at point A, and it is equal to summations E at point B. So this is the main things that you want to test you in this question. See whether you understand it or not. All right. So let's see how are we going to solve a point A. If you look at the questions, there's no spring. It only involves motions and change in position. Therefore, again, okay, we are going to look at what happens to UG and also K. No spring, no US. So A, okay, summations E initial equals to summations E at point A. Okay, because now I want to look at what happens at point A. So K initial plus U initial equals to K final plus U final. Based on my questions, object come with initial speed. Therefore, I have to keep my K. It comes with a height which is 5 meters. It got U. And then final positions at point A, it got K because you want to calculate the speed. But then the UF, you can cancel it out. Why? Because at point A, now I'm taking the ground as the H equals to 0 again. So at point A, your H equals to 0. So UG is equal to 0. All right. So now let us expand the equations. So K initial 1 over 2 mu square plus mgh initial equals to 1 over 2 mv squared. So that is our equations. Okay, that is our equations. So what next? Okay, so next one, we're going to substitute the value. So 1 over 2. Now, again, if you look at the questions, we're not given m. Okay, but then you look at the previous step. Okay, this step. Every single variables, okay, every single one, they come with m. So you can cross it out. Okay, you can cancel it. So 1 over 2 u square, which is a 10 square, plus 9.81 initial height is 5 meter, equals to 1 over 2 v square. So from here, you obtain v is equals to 14.07 m as negative 1. All right, so that is for point A. For point B, okay, you can use summations E initial equals to summations EB. Okay, or you can even use summations EA equals to summations EB. Okay, both are accepted. But now I'm going to use summations E initial. Why? And actually, I encourage you to use summations E initial because we don't know whether we make any careless mistake or not in questions A. If you have careless mistake and you got the wrong V, then it means your questions B would be wrong, right? So to prevent any possible careless mistake, I always use the initial state rather than summations EA in my calculations. Okay, because initial state, the values you obtain it straight away from the questions, so it is impossible to have any careless value in it. So again, I'm going to write it down first. K initial plus U initial equals to K final plus U final. Okay, now K initial and U initial, we know it's a non-zero value. How about K final? K final, of course, is not 0 because it asks you to determine speed. And then U final now is also not 0 because you have a height which is equal to 3 meters. Okay, so which means now we're going to plug in everything. So 1 over 2 mu square plus mgh initial equals to 1 over 2 mv square plus mgh final. Okay, again, we don't have m, but then all 4 of them, they come with m, so we can cancel it out. Okay, cross it out. So don't include m in our next step. So 1/2 10 squared plus 9.81 times with the initial height equals to 1/2, and then your v is the things that you want to calculate, plus 9.81 times 3. Okay, therefore v is equals to 11.8 meter per second. Okay, 11.8 meter per second. So that is the answer. Right? So I give you 2 minutes to write it down before we proceed to the next question. Okay, the key point in this question is it wants to test whether you understand this one or not. All right, and for questions B, you have 2 methods that can be used to solve it. So it is up to you which one you want to use. So 2 minutes for you to write it down. Then we're going to proceed to the last question for today's section. Okay, last question is slightly more complicated. So we're going to use more times on it. All right, so now let's proceed to the last questions. Okay, last question. These questions is a bit, I would say it's a bit tricky. Okay, why a bit tricky? Because it doesn't tells you where is h equals to 0. And if you use different positions, then you are going to get, you are going to use different methods to solve it. Okay, so that's why I say this question is a bit tricky. Now, for me, I will use, the vertical, the horizontal plate. Okay, so let's go through the question first. So the questions tell us what? Okay, wait, yeah. So according to the questions, an object of mass 2 kg, now you have a 2 kg mass here, this is 2 kg, is placed 2 meters directly above the top and a vertical spring of a top end of a vertical spring, as shown in figure above. The spring comes with a spring constant 500 Newton per meter, determines the maximum compressions undergone by the spring when the object falls on it. So how are we going to determine the maximum compressions? Obviously, we need to compress the spring. So we'll have a final state, okay, given initial state. So now let me show the final state. Okay, so final state, now the spring being compressed, and then object is falling on top of it. Okay, so this is the final state. So what we want is the compressions. Okay, it's the compression from here until here. This is a compression. We want to find the values of x. Okay, now how are we going to solve this question? Should we take ground as our unknown, as our h equals to 0? Well, of course you can, but it will make the question slightly more complicated. And I'm going to take the horizontal plates here as 0. Why? Because I want to introduce a new thing to you, which is what we call negative h. So initially, object is located at 2 meters above the h0. So your h initial is a positive value 2 meters. And then, okay, when the object falls on the spring and it compresses the spring, now what happened is that, okay, my h is now equals to a negative value, okay, because it is located below h equals to 0. Okay, it is located below h equals to 0. So now you have a negative value, and this negative value is equals to the length of the compression, negative x. So the most important thing is you have to know H can be a negative value. It can has a negative value. All right. If you take the H0 above the final position, then the H final is a negative X, negative value. All right, now let's see how are we going to solve this question. This question apparently comes with a spring now. Okay, an object, you drop it, it's moving. So let's start from summations E initial equals to summations E final. Okay, then I'm going to include all three of energy, all three types of mechanical energy now. Why? Because now my object experiences a change in position. My object is moving with motion and it has a spring in the system. So I'm going to write K initial plus UG initial plus US initial equals to K final plus UG final plus US final. Okay, plus US final. So what happens right now is you have to go through the questions again and see which can be removed from our equations. So now you drop an object. Before you drop it, we have initial speed equals to 0. Therefore, K initial, you can remove it. Okay? And then G initial, well, you have a non-zero H initial, non-zero HI. Therefore, you keep it. Initial state, at its initial position, which is here. Okay, this is your initial state. At its initial state, there's no spring in the system yet. Okay, it hasn't involved the spring. It hasn't compressed or stretched the spring. So you can remove spring from the equations. Okay, and then you drop the object. And what happens at the final state? Okay, this is the final state. So at final state, now at maximum compressions, what happens is that your object will stop. Therefore, V is again equals to 0. So even though my object is moving all along the path, it's moving with motion, but because of the initial and the final state, okay, where initial is dropping, final, well, you have it at this fixed position. It stopped when it reached the maximum compression, just at what happens when it reached the maximum height. At maximum compression, object also stop for a moment. Okay, therefore, by looking at just initial and final state, we can cross out the K from our equation. Okay, but if you take any point in between the initial and the final position, K is a non-zero value. All right, keep that in your mind. Okay, K is not is the non-zero value in between the motion, in between the initial and final state. And then the final positions, my H final again is a non-zero value, and in fact it is a negative value. So you just keep it in the equations, and now it involves compression. So of course there is elastic potential energy. So after I simplify the equations, now what do I have? I just have UG initial, UG final, and US final left in my equations. All right, so next step, I'm going to expand it. So U initials, MGH initial equals to MGH final plus 1 over 2 kx squared. Okay, now when it comes to this one, you cannot cross out the m anymore. Why? Because the last one, 1 over 2 kx squared, it doesn't have m. So you need to keep the m in your calculations. All right, so now I'm going to substitute the values into the equations. So I have m is 2 kg, 9.81. And then what happens to my H? My H is 2 meter. Okay, equals to 2, and then mg, which is 9.81, and now my H is negative x. Okay, it is a negative value, plus 1 over 2, and then 500 x squared. Okay, so your equations now is just left with one unknown, which is x. So rearrange the equations and solve it. Eventually, you will get x equals to 0.437 meter. Okay, 0.437 meter. So that is our final answer. So the crucial part in this question is how to determine H. Okay, a lot of students, they cannot answer this question because they don't know H can be negative value. Okay, H could be a negative value. Why? Because now it is located below H equals to 0, right? And if you choose ground as H equals to 0, then the whole step, it will be a slightly more complicated. You will have more unknown in your calculation. So one of the technique in solving vertical questions is to determine where is your H equals to 0. Okay, and the best solution in this question is by taking the horizontal plate above the spring as H equals to 0. Then from there, we solve it. Okay, from there, we solve it. Okay, so that is the last questions for today's sections. If you're done, then you may leave the class. Okay, if you're done writing it down and no questions, then you may leave the class.